Let's take a look at Tropical Cyclone Alfred, its unique weather patterns, and the potential damage to buildings. According to S&P Global Ratings, insurance payouts from Alfred could reach up to $1.3 billion. Alfred formed on February 22 over the Coral Sea, initially showing signs of a typical southward movement. Early forecasts suggested it might stay over open waters, avoiding land. On March 27, Alfred temporarily reached Category 4 strength. This intensification was driven by warm sea surface temperatures, providing the storm with the energy needed to strengthen rapidly. As the storm moved further south, encountering cooler waters and increased wind shear, it gradually weakened to a Category 2. Then, surrounding pressure systems pulled Alfred to the west. Alfred eventually made landfall near Brisbane as a tropical low. Cyclones making landfall in tropical areas like Brisbane is a rare occurrence. Climate scientists say these out-of-zone cyclones are becoming more common due to climate change. Next, let's look at the regions impacted by strong winds. The areas highlighted in green represent regions where maximum gusts exceeded 30 meters per second, or 67 miles per hour. Historical data suggests that wind speeds of this magnitude can cause damage to buildings. The strongest winds were concentrated around the cyclone's eye on the sea. Alfred weakened several days before making landfall, reducing the area of strong winds. From the map, we can see that there were almost no strong winds in the inland areas of Australia. Next, let's examine the regions impacted by flooding. Flooding is known to have a high correlation with 24-hour precipitation, and areas where this indicator exceeds a certain threshold are shown in blue. It can be observed that heavy rainfall occurred around the eye of the cyclone, overlapping with the areas where strong winds were experienced on the sea. However, in Australia's inland areas, the rainfall remains strong even as the storm weakens. And Alfred has brought very heavy rainfall to the areas around Brisbane. Before diving into damage predictions, here's a look at the building distribution in the affected areas. The flashing regions indicate areas with a high density of buildings. This analysis uses a global building database with a resolution of 250 meters. Based on the building database, we have mapped the number of buildings aggregated for each local government area. Brisbane has approximately 390,000 buildings, Gold Coast around 200,000, and Logan about 160,000. Using this building data, alongside meteorological information, the estimated number of buildings affected by strong winds and flooding is calculated. The map shows the estimated number of damaged buildings. The areas shown in pink indicate regions with a high number of affected buildings. The most significant damage is expected in Brisbane, with an estimated 33,000 buildings affected. Logan and Ipswich follow, with an estimated 16,000 and 12,000 buildings affected, respectively. The percentages represent the ratio of affected buildings to the total number of buildings. For a more detailed view, yellow bar graphs show the affected areas and the number of damaged buildings. Longer bars indicate higher damage counts within each grid. The damage extends across wide areas of Brisbane and Logan. In Brisbane, affected areas are located along the Brisbane River. Similarly, in Logan, damage is expected around the Logan River, which flows through the city. Thank you for watching. Don't forget to subscribe to stay up to date with the latest information.